Hello students, this is Shweta Patil and I welcome you all to the video lecture on computer organization. So today in this lecture I'll be explaining about module 3, that is memory system, within which today I'll be discussing about semiconductor RAM memories, the concept called as internal organization of memory chips and static memories. Okay. So let's move to internal organization of memory chips. What this is, you can look at the figure how the organization of memory chips are. As you all know, memory cells are organized in the form of an array and each cell is capable of storing only one bit of information. So you can look at in the figure, many cells are arranged in rows. How they are arranged? Many cells are arranged in rows. Okay. So one word line contains some set of cells. As you can look at in W0, with a line W0, I am having many cells B0 till B7, means B0 is within one cell, B1 is in one cell, B2, B3 likewise till B7, means 8 bits are there under one word line. In the similar manner, word line 1 W1 again is having 8 bits, it continues till W15, and it's not that only B0 till B7 should be there or W0 till W15 should be there, it depends on the size of the memory. Okay. So the row of cells will constitute a word and all cells of the row are connected through a common line called as word line. What they are? They are called as word line. Okay. So the cells in each of the columns are connected to sense or write circuit by 2 bit lines. You can see in the figure, the sense and write circuits are there, right? These sense and write circuits are connected to these cells through 2 bits. If you go through the sense and write circuit to the rightmost side in the figure, they are connected through B0, B0 bar. Next circuit is connected through B1, B1 bar. Next B2, B2 bar, likewise B7, B7 bar, isn't it? So each of the sense or write circuits are connected to the data input output lines of the chip. You can also look at these sense or write circuits are connected to the cells by bit lines and sense or write circuits are connected to the data input output lines. You can look at B0, B1, B2, they are bidirectional, means from bus the data can be carried towards the sense or write circuit, or from cells which are above, from those cells the data can be transferred to the bus through this sense or write circuit, isn't it? So this is why they are bidirectional. We can input the data into the memory and we can output the data from memory, that is we can read the data or we can write the data, isn't it? So during a read operation, what happens? The sense circuits will read the information. How? So one of the word line will be activated, means address of the memory will be given by the processor, isn't it? That address is decoded and one of the word, according to the address given, one of the word line becomes active. So which word line is active? Those bits, the cells of those word lines will be transferring, will be giving the information what all is stored on to the sense or write circuits, and this data will be transferred to the bus through B0, B1 till B7 bits, isn't it? During read operation, the data from the bits or the data from the cells of the activated word line are transferred to the sense or write circuits and given to the bus through the B0 till B7 lines. During write operation, what happens? Sense or write circuits will be receiving the input information, will be receiving the input information and store them in the cells. So already the bus contains the data, that bus is taken and stored into the cells of the activated word line. This is how write operation takes place. So whatever figure you are looking at, it is an organization which shows 16 into 8. The memory size is 16 into 8, 128 bits. Okay. So the data input and the data output of each of the sense and write circuits are connected to a single bidirectional data lines. This will be connected to the data bus of the computer. isn't it? So we are having two control lines. One is r/w bar, which is representing r as read and w bar is for write. Means if input is 0, then it is writing, if input is 1, then it is reading. So r/w bar specifies the required operation, that is either read operation or write operation. Then what CS will do? CS is nothing but chip select. It selects a given chip in a multi-chip memory system. We are having multi-chip memory system. One of those chip will be selected by CS. So this is how the internal organization of memory is, right? The internal organization of memory is. So in total, how many lines we are using? 4 lines are there. You can look at A0, A1, A2, A3 are the 4 lines which are used for addresses. B0 till B7 are the 8 lines which are used for data. So 8 plus 4, 12, and 2 more lines as r/w bar and CS. So in total, I need 14 external lines for this organization. 128-bit memory chip needs 14 external lines, but it can have other 2 also which are neglected, that is one is for power supply and the other is for ground, isn't it? So we are having external lines for address, data and control signals carrying of these. Okay, if I elaborate this 128 into 8 if I do, then it may require 19 external connections and all. This is how the internal organization of the cells will be. Okay. Then moving to the next topic, that is static memories. In static memories, 2 types of organization is shown. One is static RAM cell and the other is CMOS memory cell. 2 types are studied within this static memories. What is meant by static memory then? The memory that consists of circuits capable of retaining their state as long as power is applied. If power is there, then the supply will, if supply is there, then the circuits are capable of holding the data, else no. Those are named as static memories. Okay. So we have 2 types of static memories which are dealt here, static RAM and CMOS, isn't it? So moving to static RAM cell, you can look at in the figure, I am having 2 bit lines B and B bar, maybe B0, B0 bar, B1, B1 bar, B2, B2 bar. So this is for one cell. Remember, this is for one cell and thus cells will be many in number as shown in the internal organization in the previous topic, isn't it? So 2 transistors are used, T1 and T2, and 2 inverters you can look at. You are having 2 inverters. Which are the inverters? 2 inverters are there. Fine. 2 transistors, 2 inverters connected to the bit lines, right? 2 inverters are cross connected to form a latch. How they are connected? They are cross connected to form a latch. These 2 are connected through transistors T1 and T2, right? So the 2 transistors act as switches, that is they can be opened or closed under the control of word line. If I activate the word line, if this word line is made 1, input to the transistor will be high, that is why the 2 transistors T1 and T2 turn on. If they turn on, they connect B to X, B bar to Y. So whatever is stored in B will be connected to X and whatever is stored in B bar will be connected to Y, or X is connected to B, Y is connected to B bar when I turn this word line high. If this is low, then the 2 transistors will be off. Okay. When word line is 0, transistors are off. When word line is 1, transistors will be on. Then let us study how read and write operation happens in this. So in order to read the cell, the word line will be activated so that T1 and T2 will close. They are on, they will be closing. They close the switches, means they are on. If the cell is in state 1, if the content of the cell is 1, then the signal on the bit B is high, and if the signal then B bar will be 0. If B is 1, then B bar will be 0 automatically, or else if the cell is 0, if the cell is having 0 state, then x will be passed to b, x is now 0, that is why b will be 0 and b bar will be 1. This is during read operation. What happens in read operation? The selected content of the cell is transferred to the bus, that is why the content of x is moved to b and y is moved to b bar, isn't it? Word line becomes active. Upon activating the word line, the two transistor close the switch, that is why the content of x whatever is moved to b and the complement of it will be moved to b bar, isn't it? If x is 0, b will be 0, if x is 1, b will be 1 and opposite will be present in b bar. So, this is how read operation takes place. Now, how write operation takes place. So, the state of the cell is set by placing the appropriate value on the bit lines. So, now bus carries the data. Assume b is 0, b bar is 1. Activate the word line. Upon activating the word line, the two transistors will close, that is they become on. Whatever is there on b will be transferred to x, that means from bus I am transferring the data into the cell. b 0, x is made 0. If b carries 1, x will be made 1, isn't it? So, this is how write operation takes place in static memory, static RAM cell. Okay, this is little bit time consuming, some delay may be there which is incurred because of the inverters. That is why an advanced technology comes, that is using CMOS memory cell. You can look at in the figure, I am making use of 6 transistors. How many? 6. T1, T2 act as same as in the previous diagram. Then instead of inverters we are having T3, T5, T4, T6 which carry the same functionality as that of inverters, right. So, now CMOS realization of the cell has to be done. The transistors pair T3, T5, then T4, T6 form the inverters. T3, T5 form one inverter, then T4, T6 form one more inverter. Okay. So, in state 1, if the cell is in state 1, the voltage at point x will be high, isn't it? Means x is equal to 1. So, this by having transistors T3 and T6 on, okay, while T4 and T5 off, T3 and T6 should be on and T4 and T5 has to be off. When I turn the word line active, T1 and T2 will turn on. Okay. Now, this high state, if whatever the high state x is at what state, that will be transferred to B and opposite will be transferred to B bar, isn't it? What all is to be done? I have to transfer the data from x to B and y to B bar. So, for that I have to make T1 and T2 on, that I can do by making word line high. If the content of cell is 1, means x is 1, I can transfer it to B. How? By making T3, T6 on. 1 means T3 and T6 will be on, T4 and T5 will be off. Opposite for 0. If it is 0, then T3 and T6 will be off, T4 and T5 will be on, isn't it? Thus, by turning the word line to high, I can transfer whatever is there on x to B and whatever is there on y is nothing but x bar, isn't it? That will be moved to B bar. This is how a read operation can be done, right. During write operation, already bus contains the data. So, B will be 1 or B bar is 0, assume B is 1, turn T1 and T2 on by making word line high, I will be turning them on. So, this B will turn to whatever the content of B is will be transferred to X by T1, which turns T3 and T5 on and T4 and T6 off. The same is with respect to 0, then opposite transistors will be on and off. So, this is all about the CMOS memory cell, which is more advantageous than that of the previous case. In the next video, I will be explaining about asynchronous and synchronous DRAMs. Thank you.